Hello everyone, I'm Jana. I'm your tech support during the tutorial. I want to introduce you to our tutor, Aleksandar Petrovic. He's a teaching assistant at DSC University and he will hold the Create ML framework Introduction to No-Code ML tutorial. So enjoy.
Hey, hello everyone. Hope you can hear me. All right. As Jana, right, said, I'm a teaching assistant. Yeah, okay. Yeah, I'm a teaching assistant here at Singidunum University, and I also started this year my PhD studies in artificial intelligence. So this is a topic very familiar to me and something in which I'm interested, not just as a hobby, but rather as my future profession. So if that information means anything to anyone, you can contact me however you want. I will provide my contact information at the end of the presentation. So let's just share my screen for the start here. Okay. Okay, Zoom is asking me to quit and restart because it won't let me share my screen to do some permission. So I will briefly exit the call and I will be right back.
Sorry for interrupting. I'll make sure to make you a host so you can freely share your screen.
Okay, am I sharing the screen now? You should be able to see it.
Yes, we are. We can see it.
Okay. Thank you. Okay. So a little bit on the topic before we begin. This framework is relatively new as it was introduced a couple of years ago, but still there is very little material on the topic. And the idea behind it is very all of us. I believe that even commercially, that these no-code AI solutions will play a significant role in the industry in the near future, as you can already see some of that progress being made by all of you have heard, and it cannot go without you cannot talk about AI today without mentioning ChatGPT. But what I want to tell you about it is not about ChatGPT itself. I believe you're all familiar, but the thing that has happened after, or that many people have created GPTs of their own through their API and for various purposes, which is still not as good as no code, obviously, having a full integrated development tool that you can create a full app with only your mouse, without any keystrokes. So it's still not there yet, but if we provide a way for people to do machine learning without even knowing how to code, I believe that is when the revolution will start. Because, for example, take Photoshop's AI or Adobe's rather technologies that they have used in their newest version, the Photoshop, their most popular app. Things like these tools, and I'm talking about the generative fill function, where you can simply generate literally pixels around it that are similar to the pixels that you already have, and something that is supposed to go there, the algorithm will predict and put this. So what does this feature do for the rest of us? Well, my artistic side is, or rather my drawing skills are very bad, and naturally Photoshop doesn't sit right with me as well. I'm more on the technical side. But the thing is that now I don't have to be so good at Photoshop to create an amazing idea in my head, and it's much easier to manipulate certain operations because AI does it now for us. So the gap here that the AI is bridging is that learning curve for every tool that we have virtually in the for coding or anything computer related. This tool can the AI can enhance those tools and can bring them closer to people that haven't dedicated their whole lives to learning something. So I believe that the beauty of it lies here, and that this is the potential which should be emphasized throughout. And just a small note before we begin, and that is that this framework can be buggy. So I encountered crashes which were not due to hardware capacity exceeding of my machine. I didn't do anything too hardware demanding, as we really don't have the option for that in this framework. It's focused on a fixed set of algorithms, models that are pre-built. So okay, maybe we can go to next slide now. The contents of the today's workshop. We're going to talk a bit about the create ML, which I will continue. That I have the sentence I've stopped in the middle just before. So we're going to get to know what is create ML, since we are we are already halfway through to getting familiarized. We're going to talk a bit about the benefits, and then, since the accent is no code, just to prove my point, we will start from scratch on some machine learning concepts. We will touch upon the metrics that are used. So just to make sure, since this is a tutorial that is beginner friendly, and when I say that, I mean complete beginners, because it's really nothing too complicated in terms of manipulating the application itself, in which we will be working today. But you can take anyone and just tell them click here and click there and you will get this, but what happens after and the evaluation of the results requires some prior knowledge in the machine learning and the metrics. So I will try not to bore you with these fundamental things, but some of them we will have to cover. So for today, I've prepared 4 examples, and these examples include what I consider to be necessary for you to get into machine learning. And for me, it's kind of natural to start with maybe regression, but classification has always felt more natural to me to come before regression. So we will, we say here tabular because our data will be in a table in a CSV file. So this is how most data sets are stored. There are other examples like TXT files even, but the second most popular would have to be the JSON format for certain data sets. But for the ones that we'll be using today, we have only we have only CSV files for these files. So we will cover classification. That is when you have class 1, class 2, the model decides which one is it. Regression is when you have a number, for example, an amount of money. That this is maybe the most interesting to predict for everyone. How much something costs, how much money will we get from something, and so on. So this is the regression, the continuous variable, where a number can be from 0 to anything above with any amount of decimal spaces. So we cannot know for sure if we have 1 case or 100 or 1,000,000 and so on. So this is the regression. After that, we will have an example for image classification, which is which will be playing cards, which will allow us to of the create ML. So once you train a model inside create ML, you can and you have testing data as well. If some of these concepts are confusing you, feel free to ask a question and I will explain them anytime. I just have to mention some concepts with detail about for this topic. We can turn on the live preview, and this is the best to show with image classification, as we can simply point up a card here that we have. So let me grab my playing cards. I got some bicycle playing cards here. And let's see, we have 3 of diamonds. I will point up the card up like this. Obviously, it won't be blurred. Then I will have to turn off this camera here, and the tool will output the card that it thinks it is. So it will say with a certain amount of confidence what is the chance of that being the correct card that it thinks it is. So this is really fun. And lastly, we have a hand gesture example, which is similar to the previous one, but the thing is that it will map out points in our hand, and as we move our hand, those points will move, and based on those, you can see if it's a peace sign, if it's stop, if it's rock, scissors, and so on. So that is the point of this example. And lastly, we will have the summary. Okay, so back to the create ML. What were we talking about? This is, I would call, still a work in progress. I mean, you can, it functions. It's an overstatement when I say that it's a work in progress. But let's say that there is much more work to be done on this platform, because with the settings of parameters, of algorithms and such, during the work with this framework, some of the things were just not working as expected in terms of setting the values of hyperparameters, but we will get to that. And the point of this framework, so let's just focus on the good side first, because there are many, not to mention the learning part for people just to see that the machine learning is not really that scary. So it is a machine learning framework by Apple. And the idea is for you to have, so all of these algorithms that we use for predictions in machine learning have to be coded. So we have to be, you have to have a code for that algorithm and its procedure. So what is done here essentially is that code is already written, because most of you probably know that just coding the algorithm is not really what the AI will working with Python. Is that we have the libraries, all of them have, not all of them, but we have the models, or rather the code for these provided already, and we just import them. We don't always create. One of the algorithms is, let's say, random. This is just loaded here. Also, we're going to see other applications of create ML features. So obviously not for only these examples I've given. It can do more, but I have taken these as the best one today. So really, a quick start is an understatement in this case, because you can literally train a model in 5 minutes, and you will have a working predictor. Well, not the most precise. So this is why I say that this can still be improved a lot, because necessary visualizations of the data, which help us tune the model, and other options which are very easy accessible in with other programming languages is not available here, because with these GUI based work environments, we are very limited with options, and it allows for smooth integration into Xcode built apps. And what they say with this, I mean, drag and drop the model, watch, or iOS apps. So this is the point why this framework was created, so we could have these elementary AI features in our apps. And I believe that Apple is heading towards that on-device AI availability for their future models, and that this framework will expand after the commercial part of that technology is developed. Okay, so with this we'll finish the introduction, and just to review some of these that we have maybe already mentioned. So it is inviting for beginners. You will see that with today's examples that you can easily do machine learning as well. Absolutely zero coding is required for the model part, but if you want to integrate to a Swift app, this no coding part goes out the window, and you will have to input some lines of code, obviously, but today's topic is not Swift, and we would have to cover a lot in terms of application building in Swift. So this part we won't be doing, but I will show you how the drag and drop feature, that's right here, works, and how are we have to know anything about not even which algorithms exist for this to work. Obviously not for the best result possible, but let's say that you have the problem of image classification and you're not sure what to do. There is an setting, a tick mark that says auto settings, and this will pick the algorithm, its settings for you, number of iterations, and so on. So this is really, really great for those that literally know nothing about machine learning. And it's, I would say, a first step. The CreateML app also provides clear result interpretation, and we can see this later on the example of playing cards, because it's going to show us which card is confused the most times with another card. So for example, 2 of diamonds gets often confused with 3 of diamonds, and stuff like that. And we'll get the whole list of the cards which are getting inappropriately predicted or detected, actually. So we can say that this is a card detection model. Pre-built models, we explained this. The Apple ecosystem integration, where the Apple is trying to make one app for every of their devices, so it can work on all of them, and you can just install it. So this obviously goes online with it, and you can integrate ML models into any app that you can build in Xcode. Okay, so it provides limited model tuning, and some of the hyperparameters, which I'll get to what are in the machine learning slide, it is available for you to tune them, but I think you will see today when we head over to the app that some of these just sliders can be, or rather pickers can be buggy, and certainly only the parameters Dave wanted are selected for algorithms Dave wanted. So you don't really have a lot of freedom here, which would be needed for fine-tuning, say, and this is why this is one of the limitations of the framework. Obviously, the limited number of algorithms as well. Detailed performance overview. We will discuss which metrics are used and what do they mean in the following slides. And probably the biggest limitation is the model customization, because we cannot customize our models since they're already pre-built. We don't have any information on their architecture and so on. So for example, for CNNs, which convolutional neural networks, for those not familiar, require architecture tuning, because how many layers will you have affects the performance of your model. So you have to fine-tune these parameters as well. So obviously, this is where the power of this framework stops, and we're supposed to do that manually. So, okay, what can create ML do? Okay, all of these have went into the next line. I haven't. I tried to separate them in how they're separated in the app. So let's start with image techniques that are available. So we can apply the style transfer of one image to another, which is a style transfer technique. We can detect objects, so we can provide an image, and we can have a cat and a dog, and it can say this is cat, this is dog. We have regular classification, so we just point picture of me, and it says this is Aleksandar, and so on. The multi-label classification, where it can detect multiple labels on the same picture. So this would be rather a cat and a dog, and this would just be a dog, and a cat would not get any attention. And hand pose classification, this we have talked about. It can also predict videos, the same style transfer. It can predict actions and hand action classification. So it's not just hand pose, but rather if you're waving, or I don't know, maybe we're punching something, not to use the gestures now that are aggressive. I can't think of any other gestures with my arm that are appropriate for showing right now, with my hand actually. So for the text, we have the text classification and word tagging, which allows us to extract the meaning from text. A regular table is table predictions are classification regression, and we have the recommendation, which recommends the result to us, what would be best to do with data. We have activity classification, which is what would be most familiar to you is walking, running, swimming. So how those apps on all those fancy new watches work. So this is what that means. And we have sound classification, where it can recognize sound waves of someone else. So some of these can get more complicated, so we'll focus on the examples I've shown you. And now to get to the machine learning part, the type of machine learning which we'll be doing today is supervised learning, which will mean that we have labeled data in which our algorithm knows what's inside, not what's inside, but rather what's the data about, what it represents. And it will be making relationships between the inputs and the targets. So target variable is something that we will try to predict, and it is one of the values from the table. So we will have a CSV, and when we open that, we will have columns, and each column represents a feature. So one of those features is not a feature, but rather a target, and we will be studying dependency of every other value based on this feature. Okay, so it is focused on generalization or generalizing power to generalize the information that it's given and to recognize it. And it is an iterative process. So it all of these techniques are iterative, and they study and they perform mathematical operations that give them results, which help them modify their future predictions and their judgment for the new data that's not familiar. Okay. For the model preparation, we will have to train it on the model data. We'll have to validate and do test on data which the model doesn't know what is the result. This is what we care about. So all of the metrics that we will care about are for this part. And these two will rather relate more to how we will tune our model. So we have the model evaluation, which can be performed in various ways. We can evaluate its performance based on the metrics I mentioned. We can use benchmarks, and so there is a lot of different benchmarks in the field. In terms of, we can have benchmarks that are benchmarks as you know them, like a GPU benchmark that you would take. So a stress test and see the results it provides, or we can literally benchmark it against other solutions. So let's say that we have 3 algorithms doing the same thing. What we would do is compare them to each other and pick the best one. So in these terms, benchmarking and real world use. So the hyperparameter tuning for us, because it will get us the performance that we want. And you can think of this as settings of the algorithm. The settings need to be no single algorithm has perfect performance for every solution. So a solution for problem, which means every time we usually do this by trial and error, which is rather painful, and you will see some of it today. But there is a more elegant solution with an optimization. It's too much to cover, but this in this way we take an optimization algorithm and we let it train on the hyperparameters of the model. And what I haven't mentioned about the hyperparameters is that these values or these settings are called hyperparameters because they cannot be trained. You cannot get them through training of the model and cannot improve them. But what you can do is you can take a different algorithm and let it have the hyperparameters here and as a training data, and it can provide you the optimal values for those hyperparameters. So this is what's called hyperparameter tuning. Okay, quickly, for the metrics that we'll be using today, we have for the classification problem, we have accuracy, precision, recall, and F1 score. So these are all similar, but have different meanings. So the accuracy is overall predictions, so all correct predictions over all other predictions. So correct and incorrect. So this is what we call accuracy. Precision is the number of correct identified values over the correct identified and the falsely identified positive values. So just to make this simpler, we have true positive and true negative, and false positive and false negative. So for precision, it's true positive over true positive plus false positive. So we can evaluate how precise it was. How many times in percentage did it predict something as true, which was not. For recall, it is the same as precision, but this time it's over false negatives. So these are all the values that are predicted as positive over the true positive values plus the false negatives. And F1 score is derived from precision and recall. So it's 2 times precision times recall over the precision plus recall. So with senses of how our algorithm is correct in its predictions, and they help us tune this. So since we have true positives and false positives here, or true and false predictions, for the regression, we have to work with numbers. So these are more number-based metrics. We have the mean square error. So this is the difference of squares of the predicted and the true value. So how much we missed. Mean absolute average error, or MAE, is the same as the MSE, but it doesn't use squares, but rather absolute values, which makes it more linear as the values are not getting squared. And this can be more punishing to large errors. We have the R2 score, which is, the coefficient of determination. So with this, we evaluate how related are the X and Y, how much of the variation in this relation exists. And the root mean square error is similar to the mean square error, but obviously it has a root. So an advantage of this is that we have values in the same format in which the values from our data set are used. Okay, so the first thing you would have to do is install Xcode. So the create ML is a part of this environment, and under the developer tools, you can get to this part. So, or actually, wait, maybe I shouldn't have stopped sharing yet. 1 second. Okay, so I will open this, but since it's already here, or maybe yeah, let's just open the app, and I'll start talking about this here. Let's stop this. Okay, you should see my whole screen now. So I will open Xcode. And here we don't have to create, we don't have to have the Xcode project at all. We can simply head over here, open developer, create ML. So the first thing that we'll get is this tabular classifier. So what we have here is floating shop trends data. So what types of clothes and when do the people purchase them. So let me just show you here. So I will open this with the, okay, I thought, yeah, never mind. Since this is how Excel opens CSV files, let's quickly create a blank workbook, and I'm going to go over to the data tab and import this text CSV. Okay, and now it will be in tabular format, and I will just convert this to range since I prefer it that way. Okay, so this is the first data set that we have, and let me just share the link from the presentation to you. Okay, how do I, okay, here's the chat. Okay, so this is the first link. Data sets are all small that we will be using today, so it's not a problem for you to download them from Kaggle right away. So this is...
I'm so sorry for interrupting. Can you hear me? Just for a second.
Yep.
You didn't send it to every participant right now. You just sent it to hosts and panelists. So before you send a message, you just need to click everyone.
Thank you very much. Now
you did it. Thank you.
Now I did. Okay. Thanks for pointing that out. Okay. So we have this data here, and the first thing is that this data set is not, as you see, it's not separated into training and testing sets, which are required for model training. So what we're going to do here is we're going to look how many of them there are, and we have a column which represents IDs. So obviously this will be obsolete to use. So we will exclude this from our model, but later on. And let's just first split this into two different sets. So how we do this is naturally the split is 20% to 80 in terms of testing and training. So testing is the smaller one. So that's what we'll do here. We won't experiment too much with this. So I'm just gonna multiply it with 0.8. So in our training part, we need 3,120 entries. So what I will do here is head over here, select all of this stuff, and cut it into a new document. And just keep in mind that we have to copy headers as well. So these are the feature names, and I'm gonna click save as CSV, and we're gonna name this shop training. Okay, no, actually this was shop test, but never mind, we're gonna rename it here. So this is shop test. Okay. And the one we already have, we can just save, and CSVs should not have multiple sheets. So as CSV, and this will be shop train. Okay, so let's just open this quickly. Okay, now it's opening it in the Numbers app. It looks all right. Okay, so this is how we split our data set into training and testing parts, which are needed for the model preparation. Okay, so back to create ML. Here, I'm going to head over to my tabular classifier because this is where I placed the previous one, and I'm gonna click next. So over here, this is the screen with all the possible applications, and I'm going to use the tabular classifier, and let's see how it looks like. So we're gonna name this shopping classifier, and I'm gonna place it here. So this is the main screen of our application, and what we do now is that we select the training data. So I'm head over here since this is where my data is. So I'm gonna forward shop train, and immediately gives us an error that no target is selected. So from all of those variables that, okay, something's not right here. Okay. Okay, let's just try this again. Yes, because I have forwarded the structured data and not like this. So just don't import the CSV as I've shown you before. So how many of it? Let's say 3,120. Okay, so we're gonna find that number here. And I'm just gonna select one column and forward this here. And now we're gonna save this as CSV, right? Shop. Okay, it's the test shop again. Test shop, and shopping trends updated will be our training. So we'll just leave it at that since I removed this other data. Okay, so let's select data. So shopping trends updated. Okay, this should not be showing here. Okay, and now we can select from a list of features what we'll be predicting. So naturally, you would all go over here and try to predict purchase amount. But what we're trying to do here will be category prediction. And we're going to see in which category does our feature belong to. So category is 1, 2, 3, 4. So it's 1, 2, 3, 4. So is it blouse, jeans, sweater, and so on? So what type of clothing is purchased? And now we can select the features that we want. So I don't want the customer ID. I want the age and gender. This all affects what is purchased. We obviously can't, okay, no, it's, what is the category then? Let's see here. Category is clothing. So if it's clothing or shoes, hats, and so on, that is the prediction. And we will check all of these. So location, size. I don't believe color has too much relation, so I will exclude color. Season, rating, obviously, and all of this stuff related to the users obviously has information, so we will use all of that. Okay, and for our testing data, we're gonna pick test shop. Okay, yeah, it's literally missing the features. It's not a false error. So this is what I said to you. You have to copy this one as well. So this error should not be appearing anymore. Okay, and it's gone. Perfect. So what I've told you about the automatic setting is we have it down here. So we can choose any of these that we like, but we can also leave it at automatic. So for this example, I'm gonna say auto, and this is it. So it has 100% training, testing, and validation, since there are only 4 of the categories here, but it is successfully predicting all of them, and we can see the precision, recall, and F1 score here for the classification part. Okay, in the output, we can just click get, and once we click save, we can see that the .ml model extension here has been created, and that we have the shopping classifier. So what would we do here to get this model into an Xcode app? So let's open this. We would literally only have to drag this over here to check the copy items if needed, because some of these models have to be here. Okay, I got a question that if I could share the presentation after this. Of course, I apologize for not providing the materials in advance. I was not able to. So everything will be online along the data sets. And if we don't finish all the examples, of course, you will get all of this. And through the conference's website. All right. So this is it. We have the shopping classifier here loaded, and we can work with it. So something here, how would this look like? Is that, okay, we had this model for image input, which was something else. We forward something, the target output. So this is for this part. We won't be spending more time in iOS applications. We'll just focus on Swift, and we have to hurry up and head over to tabular regression. Okay, so actually, I will have to change the slide since I've changed the data set a bit last minute, but I believe I changed at least the link. I was sure that I changed here, but no matter, I will get you the correct link now. Okay, so here is the link for the next data set that we'll be using. Okay. Okay. So let me just open the data set itself. So here we have information about laptops, and the column that we'll be predicting is their price in euros. So this is a number and not category. So we will be using regression now. So let's get over here, create a new project, and open my tabular register. So which will be named laptop price predictor. Okay, and I'll save it here. Yeah, what I didn't mention, I'll also provide the models that we trained today. So you will get those as well, and you can just open them straight in ML and use them. So this is also a cool feature. Okay, so for this one, I have already separated the data, not to waste any more time. And let's head over to desktop, laptops, train. Okay, and we will choose the price in euros for training. And for the features, laptop ID, irrelevant. Company, not so relevant. Product, okay, we will skip this part because this is the name of the laptop and there is too many of them for these to show anything significant. So let me just prove to you that here we just have too many different models, and this will only throw off the predictions of our model. So this is why we will exclude this feature. Okay, type, sure, because Ultrabooks notebooks have different prices, inches, vary the price, a lot, screen, CPU, RAM, memory, GPU, everything, even the operating system, because we know that this can be a bit two-sided versus Mac and Windows, but the price can be seen, the price difference is observable. And we will utilize weight as well, because some of the heavier laptops usually cost more because they have heavier GPUs and components. Okay, so what I haven't mentioned is that we can use a separate validation data set, but this one here is making it automatically. Okay, so here, tests, and what I'm gonna do, okay, first let's choose auto settings. Let's see what it gets. So with auto settings, we have a mean square error of 151 on the training and 219 on validation. So this does look like a lot, but if we here take a look at this data, we can see that a mistake of 200 euros up or down is really only significant for the lower tier models. So if we have a laptop that's around 200 euros, or we are looking to spend 200 euros, we usually don't care if it's 1800 or 2200. So that's from that perspective, it can be considered a less of a mistake. So what's another fun part about CreateML? You can duplicate the source settings here very quickly. So it made a copy of this model, and we can export each one of these separately as we like. So for starters, let's try random forest, and these are the hyperparameters I talked to you about. So we're going to try just with the default ones, see if we get something better or worse. And the results are significantly worse. So training completed. Okay, let's try something else. Okay, random forest, but we're going to give it 350 iterations. And let's just leave these for now the same as they are. So you will see that actually this will perform very fast in terms of how many iterations it's supposed to take, not as fast as the previous training, but still pretty impressive. That okay, so it took 1 minute, and we see a significant improvement here in the training, but on validation, the mistake is really big, but we still can't beat the auto settings. So tweaking of these parameters would only get us smaller improvements. So maybe let's try a boosted tree for 100 iterations. Okay, so it overfit obviously since it didn't perform all of those. Let's try 30 iterations, but increase the depth to 8. And let's try to, okay, so you see here how it won't let me type what I want. So these can get buggy. So let's just try to reduce the percentage of data that is used for subsampling. So let's put it around 8.0. And let's put this one as well, see what happens. Okay, so literally almost same, a bit better than the previous one. So the idea here is to play around these, and that you can easily duplicate them and experiment with different settings while still having the previous one, and that you can here tweak these settings. You can also experiment with the number of features. So let's say I believe that these don't affect the final result that much. So let's see which was the best. 254, I believe. This was the random forest with 350 iterations. So yeah, let's try this one. And let's see what happens again. While we wait, so here we have the validation set, which came separately, but this data set looks a bit different since cards are the topic. So once we open the train folder, we have all the types of cards separated into their folders. So let's say 6 of spades here will have very crazy art and different playing cards examined and in different scales. So for the image tuning, we won't be setting the hyperparameters. Okay, this one I believe can be thrown out of the data set because it's downright horrible. But different styles exists, and the point is to predict all of the different ones. They're all in different folders, and this is how our algorithm knows what it's predicting. So let's just wait a bit for this more. It said it took 1 minute, sorry, for the previous one. This one is obviously taking a bit more. Okay, while we wait, let's set up this card classificator. So we're going to use image classification, and I'm going to name this the card classifier. Okay, so let's select the training data. Okay, that's not what I wanted to select. So we just select the train folder and all of the folders below, and it recognizes 53 classes. So we can click here, view, And we can see the count of all the classes which we have in this data set, which is extremely useful and a very nice and tidy way in Apple's manner to provide them like this. So okay, yeah, this one we can delete. So you see here that the data sources are here. Okay, never mind, this shouldn't give us any trouble. I'm going to choose the validation set since we have it. So this is usually a part of this data set, and that's why it's in most times automatically taken. And we're going to choose this. Okay, this one is still going. Okay, it's random forest, right? Okay, complete. And the results are not good. So obviously we didn't get much from that feature reduction. This would usually be performed with the analysis of the feature, their importance, the correlation to each and every one of them. That's what I said, that this this create.ml has this shortcoming because we really can't find anything here in the evaluation that we can use except these metrics above. Okay, so let's train our model here. And we have two feature extractors, the one with the resolution of 299 times 299, and the other one with the resolutions of 360. So we'll try both of them. We have the number of iterations as well, which the algorithm will go through, but we also have augmentations. So what do these do? They copy the whole data set of images and add noise to a picture. They blur, they crop, expose, flip, or rotate. And if we take all of these, they will create 7,000 and something copies of an images for each of these modifications. And this is a sort of feature engineering where we create new features by simply cropping the same picture, and we can use this as a data entry in our data set for training. So for example, let's just not choose anything here, and let's this go. Okay, just 1 second for me to check something, and I'll share the screen again. Either way, it's just running. Okay, almost finished. With the feature extraction, and it will have to train after this. So we also have those 25 iterations to run. And we can see here how the training and validation accuracy move. So this standard model obviously is not good. And okay, here are the evaluation metrics I wanted to talk about. So we have the test accuracy, and we can see here that only 111 in comparison to 150 wrong predictions were made in this case. And we can see here some of the worst with the lowest precision and lowest recall, the images or category of images rather that are used. So here we had 2 of spades 5 times, of which correct was 2 times. A false positive was 1 when it was a different card and it thought it was 2 of spades, and a false negative, so 3 times it saw the 2 of spades and it said that it was not it. And you can see here for every class, so by class, metrics are provided in this window. We can also click here on the Explore. Okay, we have the some Pokemon playing cards, not those that you would think of immediately. So this was 100% confident that it was a joker, maybe due to this curved lines or whatever, but it made that mistake. So these are all the mistakes that the program made, and how certain it was while predicting these. So we can take any label prediction result here. So let's say 8 of diamonds, and it's only going to give us the 8 of diamonds. So if you take a look up here, the top confusion is the joker as the 6 of diamonds. I don't know who made this Donald Trump playing card set, but the authors of the data set obviously thought that it was valuable to this. So yeah, this was actually mistaken for a 6 of diamonds. Apparently, Mr. Trump's face reminds our model of diamonds and number 6. Wonder what meaning is behind that. Okay, we also have 10 of diamonds as the 8 of diamonds. So, okay, this one's a bit closer, and so on. So we can literally check for bad data here. So if an error starts happening, usually with the same cards only, obviously these are not good for our data set, and we will throw these out of our data set, and it will get better results due to this. So this is one way of improving our model. Okay, so just to show you something really cool, and it obviously won't be working perfectly yet, but we will make it work because this model can be improved. And also a fun thing here I haven't shown you is train more. And you can add additional iterations to training if you believe that your model would benefit from extra iterations. So you don't have to train a model from beginning. You can literally add more iterations just on the previous model that you have built. So obviously the improvement here is very, very small, or is no, it's not even noticeable. Never mind. So just what I want to show you here is live preview. So, okay, this camera works, and I apparently look like the 10 of diamonds. So if we give it this 6 of spades, you see that it's all over the place. The closest it gets is 9 of spades. So this model, as we already know, is not very good. But the thing is that we can here take any card and show it to our camera, and here 8 of diamonds. So this was really close. We can show it to our camera, and our algorithm will work. So this part is really cool if you ask me, and it will be a lot more cool once we change some of the parameters here for our model to be better. So let's leave it at 45 iterations, but we will use the other feature extractor, probably due to the smaller embedding size that this one fits better for this problem. And I will also add blur, crop, and rotate. So noise exposure doesn't really affect too much. Flip could in the mirror, but we're not doing that, so we don't care. And let's just add these three and see how our model will be trained now. Okay, it's still extracting the features. Okay, so it is looking promising from the start. Okay, 80% testing accuracy. So now we can actually turn on the live preview, and let's say I show this Jack of Hearts. It shows us Jack of Hearts, as you could see. So let's try 10 of diamonds. This is what it usually has trouble with. And it gives us the 10 of diamonds. Okay. So let's try 6 of spades. So it thinks it's 5 of spades, but okay, it's still close. So that one has failed. So let's try 5 of clubs. So it thinks it's the 7 of clubs. So maybe we should have used the flip function as well. So let's see what will happen if we copy this. And this will be the last model we trained today. So let's try to do this. quickly and see what happens. Okay, in the meanwhile, I will just open the prepared hand gesture model. It's really not impressive. It barely works, but it only has a 68% validation accuracy. And if you take a look at this one, it had 80%. So that's around 20% difference. So it's struggling with this. And I believe that the issue definitely was the data, but I could not find a better data set for hand gesture classification. So I will show this to you. So, okay. These are the settings that we have. To flip horizontally the images, rotate, translate, and scale. So let me show you how the data set looks like. So let's say for the OK, this is how we're supposed to show our hand. And these are all black and white images. So once I turn on the live preview for this one, okay, it's going to map these dots on my hand. And okay, now peace sign is going well. Let's see, okay. Nope, it's only detecting the peace sign. So this one is not really working, but I just wanted to show you how what features are here in the create ML, and how the program itself recognizes the points on our hand, and how it works well, or rather how it should work. Okay, we're getting close to the end of our time slot. Are there any questions, not just on the topic here, but whatever you would like, whatever interests you?
If there aren't any questions, we can end these discussions. Thank you, Alexander. It was very interesting. Thanks everybody for watching. The next lecture will be held in like 18 minutes. So, Alexander, I just have a question for you. Can you provide us with the link for the presentation in the chat?
Yeah, so is it enough to share the materials with the data science conference team, or?
Yes, of course. Yes, of course.
Yeah, okay.
It's
so
okay.
I have talked with Emilia, and I will send her the materials after this. Okay.
All right. Thank you so much.
All right. Thank you, everyone, for your attention. Hopefully, this was an interesting tutorial. You've seen something new. That is all from me. And okay, you will have my LinkedIn on my presentation. So if you need to contact me, you can reach out over there. Okay, thank you once again. I'm tuning off, and I wish you a productive and interesting conference that is ahead of us. Okay, see you at the Data Science Conference.